Welcome to your IELTS Listening Practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Good morning and welcome to today's lecture on a critical topic in geochemistry, the ocean acidification process. Today, we will explore how increased atmospheric carbon dioxide can lead to changes in ocean chemistry and impact marine ecosystems. First, let's define what ocean acidification actually is. Ocean acidification refers to the process whereby the ocean absorbs carbon dioxide, primarily from human-related activities such as fossil fuel combustion. This process leads to a series of chemical reactions that increase the concentration of carbonic acid in seawater, decreasing the ocean's pH. Now, you may wonder how this all ties to marine life. The absorption of carbon dioxide is an ongoing issue that poses specific threats to various organisms, especially those that depend on calcium carbonate, such as corals and shellfish. With increased acidity, these organisms struggle to maintain their calcium carbonate structures. Thus, the overarching effect is a decrease in biodiversity and disruption of marine ecosystems. Additionally, the effects of ocean acidification can extrapolate to the entire food chain. The decline of these marine organisms disrupts the food webs, ultimately affecting larger fish species and marine mammals that rely on these organisms for food. Even though these changes may not be instantly visible, the long-term consequences entail significant implications for global fisheries and food security. Moving forward, let's discuss the basic chemistry involved. When carbon dioxide enters seawater, it reacts to form carbonic acid, which dissociates into bicarbonate and hydrogen ions. The increase in hydrogen ions is what leads to the decrease in pH. A lower pH indicates that seawater is becoming more acidic. The impact of this process is particularly severe for shallow marine environments, such as coral reefs. Corals rely on calcium carbonate for their growth and structure. As the acidity levels rise, the ability of corals to absorb sufficient calcium carbonate diminishes, leading to weaker structures and increased mortality. A detailed study published in 2018 revealed that coral reefs in high CO2 environments exhibited growth rates 50% lower than those in normal pH conditions. This alarming trend highlights the urgency of addressing carbon emissions to preserve these crucial ecosystems. Research has further shown that not all marine species respond to acidification in the same manner. For example, while some species may exhibit resilience or even adaptation, others, particularly those with long life cycles, may face extinction. Thus, understanding which species can adapt and which cannot is critical for predicting the overall health of marine ecosystems. In conjunction with biological impacts, there are also socioeconomic implications to consider. Coastal communities heavily reliant on fisheries are at risk. Predictions indicate a decline in shellfish populations, which translates into reduced income for fishers and associated industries. These socioeconomic impacts resonate beyond immediate resource availability, touching on food security and livelihood stability. In terms of mitigation strategies, incorporating sustainable practices is crucial. Various approaches have been discussed, including enhancing marine protected areas, regulating nutrient loading, and fostering resilience in ecosystems. For example, encouraging coral restoration and establishing policies that limit emissions can serve as a counterbalance to the acidifying environment. To sum it up, ocean acidification represents a multifaceted challenge arising from increased carbon dioxide infusion into our oceans. In addition to affecting marine organisms on a molecular level, it poses risks to ecosystems and human livelihoods. It is an urgent call to action for all stakeholders involved. Finally, research and considerable monitoring efforts must be intensified to track the ongoing changes in ocean chemistry and ensure that appropriate measures can be taken. In conclusion, addressing the problem of ocean acidification is paramount for ensuring the longevity of marine life and the communities that depend on it.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.